So we only have a couple more mathematical operations we need to assign to our complex value class here. One of those is if we wanted to multiply the complex number by a real number. We've got multiplication by a complex number here. But let's suppose we wanted to multiply by a real number. Let's call that real number a. Basically, all that happens is we're going to distribute the a to the real part and the imaginary part of the complex number. So we would return a new complex value of a times self.real, comma a times self.imaginary. So I've got a distributed to both. I've got the real part in the real spot and the imaginary part in the imaginary spot. Let's give this a test. Let's suppose we made z a complex value of 2 and 5. And let's suppose we wanted to multiply it, z.multiply, by a real number. Let's multiply it by 7. Now I need to print string here so that it gives me something I can actually read. And lo and behold, I get 2 times 7 gives me 14, and 5 times 7 gives me 35. So that works out the way I would expect. The one thing we haven't done yet is dividing by a complex number. So let's say we had self comma q. What are we supposed to return? You can probably imagine it's going to be a complex value, but this is actually kind of a complicated thing to work out algebraically. I've gone ahead and gotten it set up here. Suppose you've got one imaginary number z, a plus ib, another imaginary number q, c plus id. So you take z divided by q. Again, we just plug these in. This is not a straightforward thing to do, right? I could distribute a divided by c plus id and ib divided by c plus id, but you can't really distribute a denominator like that. And the trick they teach you in high school that we're going to use today is to multiply by the complex conjugate of this thing on the bottom. Remember, anytime you multiply a complex number times its conjugate, you're going to get out a real non-negative number. You're going to get out its modulus squared. So I can multiply this by c minus id and multiply the top by c minus id. So we're using the trick here that multiplying and dividing by the same thing is the same thing as multiplying by 1. So if we use the tricks we learned last time, then down here all I get is the modulus of q squared. Because last time we learned that a complex number times its complex conjugate is just the modulus squared. And then up here I've got the number z, the original number z, times the original number q complex conjugate. Now I'm not going to work out all the foiling up here or the foiling down here because we already have these operations defined in our class. So all I have to do is say return the original value self multiplied by q star. So we're going to multiply by q, self dot multiply by q dot conjugate. So this gives me the numerator. I've got the original complex number, self, multiplying by q's complex conjugate. And then all I have to do is divide by q's modulus squared. So I can divide by, oh dear, I need to, that is going to be a bit complicated, isn't it? So we're going to have self.multiply, so that's going to give me a complex value, dot multiply by a real, and we're going to need to make that 1 over q dot modulus squared. Actually, let's clean that up a little bit. Let's just make that q dot modulus to the -2 power. So rather than write out all the complicated algebra, I've written out a complicated set of function calls. But let's review this. We've got the complex number, z, times the conjugate of q, and then we're going to multiply that whole thing by 1 over the modulus of q squared. So let's give that a try. Let's make a q. Let's try out one that we know how it will work out. Let's try the number 1, because when I when I divide by 1, I should still get the original complex value. So let's try print z dot divide by q dot string. And I should get out 2 plus I5. Control 2. And lo and behold, that's what we get, 2 times I5. Let's try dividing by the number 2. Control 2. I get 2 plus I5, all divided by 2. So I get 1 plus I times 2.5. So I'm pretty confident this is working. Let's try introducing a teeny tiny imaginary part. So this should be about the same. And it is about the same. It's just basically the number is rotating in the complex plane a little bit. That's awesome. Okay, let's make this a substantial value now. 2, 1. Control 2. Oh, that's awesome. Now you never have to worry about going through all that messy algebra again. In fact, let's try one more thing. Let's try 2 plus I5 divided by 2 plus I5. This should give me the number 1, right? Oh, and it does, right? You ignore the little rounding garbage out there. So I get the number 1 out. Wow, I'm feeling pretty confident about that. To think of all the time I spent working this out over and over again in high school, and now I just have to plug it in to my lovely complex value class. That only took me about 40 minutes to develop. So I think this is a good stopping point for now. If you have other arithmetic that you frequently perform with complex values, let me know in the comments below, and we'll add on more functions to our complex value class here. So thank you so much for watching. I will see you next time. Bye-bye.